Okay, so let's try to do distance from a point to a line so you guys can understand what's going on. Again, when we are doing this, I want you all to remember that I need you to use your noggin and I need you to use the graph. So with that, let's get started. The first thing says graph AB and write the equation of this line. So we're going to do that. So while I do it up here, you guys should be working on your papers here. If I graph AB, I have the point 2, 1 and the point 12, 1, which makes a nice little horizontal line segment here. And horizontal lines have y equals equations. So this is the line y equals 1. And then it says plot the point 9, 4. So I'm going to plot the point 9, 4 and call that P. And it's asking how far is P from A? All right, so I want to do this distance right here, and it's a slanty distance. So if I want to find a slanty distance, I'm going to use the distance formula. So again, remember distance is delta x squared plus delta y squared. And let's see, P is 9, 4, and A is 2, 1. So the difference between 9 and 2 is a delta x of 7. And 4 to 1 is a delta y of 3. Now again, I know that x and y changed by a negative amount, but I'm squaring it, so I don't really need that negative. So then that's the square root of 49 plus 9, which is the square root of 58. Okay, fine. What is the distance from P to B? All right, so P to B is that distance right there. P again was 9, 4, and B was 12, 1. And so when we do delta x squared plus delta y squared, x changes from 9 to 12. So there's a delta x of 3. And y changes from 4 to 1. So there's a delta y of 3. So that's going to be the square root of 9 plus 9, which is the square root of 18. But looking at that, I'm pretty sure that 18 has a perfect square in it, and it does. 18 is 9 times 2, so that makes 3 root 2. So that's a nice quick review of the distance formula. Now, why are we doing that? Well, because my last question now is, how far is P from the line AB? So how far is P from the line that contains these 2 points? Well, P from the line is this distance away, and that distance is vertical. 1, 2, 3. It's 3 units away. Why did I ask that question? Well, because I want to compare and contrast here. The distance from P to A is not the distance from P to the line. The distance from P to B is also not the distance from P to the line. The distance from point P to a line is the measured perpendicular distance. So if you want the shortest distance from a point to a line, you have to find a perpendicular distance along a line normal to the original line. Wait, what's that word normal? Normal just means perpendicular. So anytime you want a distance from a point to a line, you have to measure from a perpendicular direction. Okay? So let's come down here and use this next one. How far is 5 minus x from the point 1, 2? Again, I want you using your noodle. I'm not going to give you a rule. There's not some nice formula for this. Well, technically there is a formula, but it's gross. I want you using your brain. So let's graph 5 minus x and the point 1, 2 and see where we go. Now, when you plot 5 minus x, I want you plotting all of the points starting at 5 with a slope of -1. I want you to draw all those dots like I did just there. And then with your ruler or a folder or whatever, I want you to connect these in as straight a line as possible. I do not have access to a ruler while I'm drawing on my screen, so I apologize for how wiggly my line is. but I do want you drawing all those dots. There's a reason for that, so draw all the dots. And it says, how far is 5 minus x from the point 1, 2? Okay, well, if I were going to draw the perpendicular distance and I didn't scaffold this question for you, if I want to know how far away they are, I'm pretty sure that this is a perpendicular, right? And so if I want to know that distance, it's however long that red segment is. So how far is 5 minus x from the point 1, 2? Well, it's however long this is. So let's kind of do the scaffolding now and make sure that we're doing this appropriately. The slope of the given line is blank. The slope of 5 minus x is a -1. So the slope of a perpendicular or normal line will be the opposite reciprocal of -1, which is 1. Draw a line through 1, 2 that's perpendicular. So I need to draw a line with a slope of 1. Did I do that? Oh yeah, I did that. Let's see. State the coordinates of their point of intersection. Okay, so this is the point 1, 2, and this is the point 2, 3. And let's see, there's the coordinates. Use the distance formula to calculate the distance. Okay, so my distance formula would be change of x, which is 1 squared, plus change of y, which is 1 squared. So that perpendicular distance is the square root of 2. Oh, so, pardon me, I'm taking a quick pause here because my little 3-year-old just came downstairs, and it's 5 in the morning while I'm recording this, so if you hear him talking, that's just Max in the background. All right, so use the distance formula. We did that. Fantastic. So let's move on to one that's slightly more complicated. All right, I'm going to stop talking for a second here. I want you guys to draw the line and plot the point and fill in the slopes. So draw the line, plot the point, plug in the slopes. I'm going to draw and plot some things, but I'm not going to talk for a minute. You should be drawing right now. All right, hopefully you all have the line drawn like mine. So we had a slope of 1/2, a y-intercept of 0. So I went up 1 over 2, up 1 over 2. And again, I want you to plot all the points because you never know which one you're going to really need for this. So plot all the points. Then I plotted the point 5, 0. And now I need to find the perpendicular distance. So we said the slope of our given line was 1/2. And if I take the opposite reciprocal, the perpendicular line would have a slope of -2 over 1, or a slope of -2. So now if I want to measure the perpendicular distance, I need to draw a slope of -2 through the point 5, 0. So my slope of -2 would be down 2 over 1, or up 2 left 1, up 2 left 1. Okay, and when I draw this in here, that looks pretty good. Now, what are the coordinates of the point of intersection? I'm not really sure. So if I want to find the coordinates of that point of intersection right there, I need to do a little bit of math. Oh, somebody should be saying in the room, Mrs. Vibber, you did something wrong. Back the truck up. Mrs. Vibber can't see her screen. I didn't do the 0.50. I did 60. So yours probably looks slightly different than for mine. Hold on. Changing things up 2 over 1, down 2 over 1. There we go. Now I have a prettier point. I knew it was supposed to be a good point, but I just couldn't read the screen. There we go. So much better. So if I draw a slope of up 2, left 1, or down 2, right 1, there we go. Now I have a happy point of intersection. Like Bob Ross with his happy trees, we have a happy point of intersection. And the coordinates of that point are 4, 2. Use the distance formula to calculate the distance between 5, 0 and the above point. Okay, so I'm calculating the distance between 4, 2 and 5, 0. So my distance is the square root of, let's see, delta x was 1 and delta y was 2. And 1 squared plus 2 squared is 5. So my distance formula gives me the square root of 5. All right. So next it says, what's the equation from number 2? So I want to show you that you can do this with some algebra as well. So if we want to find the equation of number 2, I need a slope and I need a point. Well, that's pretty good because I have the slope and the point. The point is 5, 0, and the slope is negative 2. And if I have a slope and a point, I can use that happy little equation y minus y0 equals, or y minus y1, pardon me, equals mx minus x1. So y minus 0 equals negative 2 x minus 5. And there's the equation. Then it says, what if I didn't do this right? Like, what if I graphed it wrong? Because I kind of did graph it wrong at first, right? I can always double check my work. So what I can do is I can calculate the point of intersection by using the two equations of the lines and then find the distance between the points just to make sure I have the right ones. So we have y equals 1/2 x is the equation that was given to us. And then I have the other line, which is right above it, y minus 1. If you hear my 3-year-old yelling at me, my apologies. Apparently I left his cereal in the wrong place because that's an issue. Okay. I want to know where these two things cross. When we try to find points of intersection algebraically, you guys have been taught mostly to get them both in y equals 4. So I'm going to get this guy in y equals 4. Y plus 0 is really just y. And then when I distribute the negative 2, I get negative 2x plus 10. And if I want to know where they cross, I'm going to set 1/2 x equal to negative 2x plus 10. And I need to solve for x, so I'm going to add 2x to both sides, which gives me 2.5x equals 10. I'm going to divide by 2.5 and get x equals 4. And if x equals 4, and I substitute it back into either one of these equations, y is 1/2 x, so y is 2. And that was this point up there. So I got the right point. The only purpose of that was, hey, if you graph it and you can't see a nice what's called lattice point with like integer coordinates, you could always write the equations and see where they cross. Okay. Now, we're about 13 minutes in or so right now, so I'd like to find this last distance, and then I'll be done, and then you guys can work on the problem set on your own. There is a graph paper if you need it with each of these, and I say if you need it, but really I mean when you need it. So let's try to do this last example. I will do it with you. We will be done, and we will move on. Find the distance from 7 2 to the line y equals 3x plus 1. So y-intercept of 1, slope of 3. And I think I graphed everybody appropriately this time. Oops, shifting the thing here. So like my little song. Okay. So from 7,2 to 3x plus 1. And then you're just going to find your perpendicular slope and figure out what goes on here. Notice this time I didn't scaffold the question. I just said, hey, let's do it. Not giving you all the tips and tricks. We're just going to do it. If you want the distance from a point to a line, you need to draw a perpendicular. So right now the slope we have is 3, which means our perpendicular slope is negative 1/3. Who said that? I did. So my perpendicular slope here should be negative 1/3, and I should be doing it from this point. So I should go down 1, right 3, or up 1, left 3, up 1, left 3, up 1, left 3. Okay, so I ended up hitting this point. So that's my perpendicular distance that I want to find. The point in question was the point 7,2. I bonked into the point 1,4. So if I want my perpendicular distance, I'm finding the distance between 1,4 and 7,2. So my delta x is 1 to 7, which is 6. And my delta y is 4 to 2, which is 2. And that's going to be 36 and 4, which makes the square root of 40. Now, I didn't tell you what form to leave it in, but let's just do simplest radical form to remind ourselves how that works. So 40 is really 4 times 10, and the square root of 4 is 2. So our final answer is 2 root 10. So long story short, if you want the distance from a point to a line, you need to draw a perpendicular segment to the line and calculate the distance that way. You don't have to write this note unless you think it's going to be helpful to you, but I wanted to just recap everything. So the distance from a point to a line, you draw a perpendicular segment to the line and calculate the distance that way. All right, so now I need a joke because I always end with a joke. Let's see, the joke today is going to be, what did the giraffe say when it swallowed the toy jet? So a little giraffe was playing with a little toy jet and it swallowed it. What did it say? It said, "Oh, what a pain in the neck." Ha 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 ha. I know that's not a very good joke, but let's see. I'll give you a pirate joke. What's a pirate's favorite kind of movie? Movies rated R. Why can't pirates ever play cards? Because they're always standing on the deck. All right, I'm done now. Do your homework. It's that problem set, and you should be all good. So happy graphing. Bye.